Hi, in this tutorial we're going to look at how to determine the nth term, or in other words the expression for un given the sequence. So here we're given a set of terms and we're going to use these terms to help us develop the expression for the nth term, i.e. our un expression. So for part A, let's come down here. We have 5, 8, 11, 14. Now for a sequence like this, the first thing we check is to see if we're adding a term each time. And let's see, plus 3, plus 3, plus 3, so our next term should be 17 because we're clearly adding 3 each step. Now because we're adding 3 each step, that tells me that my expression includes 3n. This is not our expression. We just know that it includes 3n because we're adding 3 each time. Now let's conclude our expression. If n is 1, for our first term we should get 5. But clearly if n is 1 here, we're going to get 3. To get 5, I need to add 2. And now we're going to see if this expression holds. So we test it when n is 2. 3 by 2 is 6. 6 plus 2 is 8. It holds. Let's test it one more time. When n is 3, we should get 11. 9 by 3 is 3 plus 2 is 11. So our un expression is 3n plus 2. Now B. Again, we realize our terms are decreasing by 2 in this case. So we subtract 2 each step. So our next term should be negative 4, simply because we realize that we're subtracting 2. Now what does that tell me? Well, that tells me that my un expression, or the expression for my nth term, must include negative 2n. But again, this is not the nth term. It just includes negative 2n. Now when n is 1, when n is 1, I should get negative 2. But my first term is 8. So to move from negative 2 when n is 1 to 8, where it should be, I have to add 10. And then we just check, let's say the next two terms, to make sure that this expression holds. So when n is 2, I'm going to get negative 4 plus 10, which gives me 6, so it holds. When n is 3, I'm supposed to get 4. And let's see, negative 2 times 3, that's negative 6 plus 10 gives us 4. So this is my expression, which you would probably more see written like 10 minus 2n. Alright, part C. Now clearly we're not adding or subtracting a constant term. So what are we doing? Well, let's look and see if we can realize any patterns. My numerators, so for fractions we generally divide it up into the numerator and the denominator, and we can look at each of them separately. My numerator goes 1, 2, 3, 4, 5, which are simply my terms for n. So I can easily state that my numerator is n. When n is 1, my numerator is 1. When n is 2, my numerator is 2. When n is 3, my numerator is 3, and so on. Now my denominators, looking at, I can see that they're going up one step. So I add 1, add 1, add 1, add 1. However, something more important is the fact that there are 2 more than the numerator. So if I add 2 to 1, I get 3. 2 to 2, I get 4. 2 to 3, I get 5. So if my numerator is n and my denominator is 2 more than my numerator, my denominator has to be n plus 2. And we can check. verify that that holds. Now on to D, our UN statement. Let's see. We have a 1, which I write as 1 over 1. That usually helps. 2, then a 3. So notice these marks here are commas, not anything else. Just commas to separate your terms. I have 3, 4, 5. Now clearly I can see that like here my numerator here is my denominator here, so that's helpful. So my denominator is 1, sorry, n. My numerator is 1 if I ignore the sign. Now we have the case where we are going from positive to negative to positive to negative to positive, and then our next term should be negative. Once we have that, we know it's negative 1 to some power, either n or n plus 1. We need to determine which one. So we check. If n is 1, negative 1 to the power 1 is negative 1, which means that my first term should be negative if I leave it like this as n. Because when n is 1, I will get a negative first term. But my first term is positive. So that tells me that my power has to be n plus 1. Now let's check. N, which is 1, 1 plus 1 is 2. Negative 1 squared would give me 2. Sorry, would give me 1. Which means then that my first term is positive. So just let me write it up here so you see. 1 over 1, negative 1 to the power 1 plus 1, if I use n plus 1. 1 over 1 times negative 1 squared, which is 1 over 1 times 1, which is 1, which is what we have. So this would be my expression for my nth term for D. Moving on to E, so my UN expression. Alright, so checking again, I'll just write this as 1 over 1. All of my numerators are 1, so that's pretty straightforward. Numerators are 1. Now I have 1, 2, 4, 8, 16. Now because I am aware of the powers of 2, I know that these numbers, my denominators, represent the powers of 2, starting with 2 to the power 0, which is 1. So I just need to write that. So 2 to the n may be your first impression. However, if n is 1, you should get 1/2 as your first term, but 1/2 is our second term. So we really want 2 to the power 0 as our first term, but to be included in our first term. So therefore I need to reduce my power by 1. Now let's check. 1 over 2 to the power 1 minus 1 gives us 1 over 2 to the power 0, which gives us 1 over 1, which is our first term. And check in our second term, 1 over 2 minus 1 will give us 1 over 2 to the power 1, which is 1 over 2. So this does work. So you just need to be careful that you have the right power so that it matches your terms. Alright, and F, our UN expression. Okay, so checking once again, our numerators are 1. That's straightforward again. Our denominators, they're written a bit differently now. And they're written like this for a reason. This is a hint. So we usually try to isolate the first number and then we work on the second one. So the first numbers are 1, 2, 3, 4, 5, which we should know by now are n. And we are multiplying using brackets instead of the multiplication sign by 1 more than the first number if we check. 2 is 1 more than 1, 3 is 1 more than 2, 4 is 1 more than 3, so 1 more than n is n plus 1. And that would be our expression for f. And you can just substitute in some numbers and see that it works. And finally, for g. And again, I'll write this as 2 over 1. So when we have a whole number followed by fractions, it's best to write the whole number as fractions so you can see the pattern. Our numerators, we're accustomed to starting with 1, but now we're starting with 2. So we're starting 1 more than n. In other words, our numerators will be n plus 1. So when n is 1, I get 2, which I do get. When n is 2, I get 3, and so on. Alright, what about our denominator? Well, this pattern is new, 1, 4, 9, 16, but really isn't new. You should be familiar with squared numbers. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So your denominators are simply n squared. And you can see why it's useful to practice so that you become familiar with recognizing these patterns. You should also be familiar with cube numbers. Like 0 cube is 0. Sometimes you can start with 0. 1 cube is 1, 2 cube is 8, 3 cubed is 27, and so on. So you should be familiar with these sets, well, this set of numbers also. And that's it for this lesson, and I hope that you were able to follow along and that you were able to work ahead of me and develop the expression for each sequence. So thank you for watching this tutorial, and I hope that you found it helpful.